Hi friends, welcome to free CCNA Packet Tracer Labs for Beginners. In this video, we are going to configure Etherchannel Link Aggregation Control Protocol, that is LACP. Before coming to this LACP configuration, if you wish to get these type of technical videos, consider subscribing. And also, if you wish to get any technical support, you can contact our team. All the details are given in the description below. Now coming to the configuration, we will have two switches, 2960 series. Consider this is S1, S2, then 4 PCs. Let me rename these PCs. Consider this is student PC1. This is student PC2. This is staff PC1. Staff PC2. Coming to the connectivity, we will connect S1 and S2 using redundancy. So here we will choose copper crossover. From S1 gigabit Ethernet 0/1 to S2 gigabit Ethernet 0/1, and we will have one more connection from S1 to S2 using gigabit Ethernet 0/2. Now we will choose copper straight through. From S1 fast Ethernet 0/1 to student PC1, then fast Ethernet 0/2 to this staff PC1. Also here fast Ethernet 0/1 to student PC2, fast Ethernet 0/2 to this staff PC2. Here we are going to configure port channel LACP between this S1 and S2 using these physical ports gigabit Ethernet 0/1 and 2. So here let me mark it port channel. We will give the number 1, port channel 1, and we are going to use the protocol LACP, Link Aggregation Control Protocol. We will create two VLANs, one native VLAN also. So let me give here VLAN 10, and here we will use 192.168.10.10 IP address for this student PC1. Here student PC2, this PC also in VLAN 10, and here we will use 10.11. Then staff PCs are in VLAN 20, and we will assign 192.168.20.10 IP address for this staff PC. Then here 20.11. Here we can see, due to redundancy between S1 and S2, this port is blocked on S2. So now we are going to configure the port channel 1 so that these physical ports will bundle and will create a single logical port. Here, before coming to this switch configuration, we will assign IP address to these PCs. So coming to a student PC1 desktop IP configuration, and here we will give 192.168.10.10, then submit to mask. And here we are not using default gateway or DNS server. Here we are not implementing inter-VLAN routing. Then student PC2 IPv4 address 192.168.10.11, then submit to mask. Coming to staff PC1 192.168.20.10, then staff PC2 20.11. Here obviously the same VLAN PCs will communicate each other. We will go to this student PC1. So this student PC1 will communicate to student PC2 because they are in the same subnet. We will ping to student PC2 192.168.10.11, and here we get the replies. We cannot communicate from VLAN 10 to VLAN 20 here in this topology because we are not going to implement, or we not implemented, inter-VLAN routing. From staff PC1 to staff PC2, it should succeed. 192.168.20.11, and we get the replies. Now we will configure these switches S1 and S2. First of all, we will do some basic configuration on these switches. Enable configure terminal. We will set the host name S1. No IP domain lookup. Coming to S2, enable configure terminal, hostname S2, no IP domain lookup. So just we done some basic settings. We did not do all the basic settings because we are focusing on LACP, link aggregation control protocol. So next we will create the VLANs on both switches. We have VLAN 10 and VLAN 20. Also we will create a native VLAN because we need to trunk between switches. First of all, we will do it in S1. VLAN 10 we will name as students. VLAN 20 name staff. Also we will create VLAN 99. This is for native. We can verify VLAN creation. Do show VLAN brief. Here we can see the VLANs we created. In the same way, we will create on S2. VLAN 10. Name students. VLAN 20. Name staff. Also VLAN 99. Name native. We can verify these VLANs using show command. Okay, here we will use do show VLAN brief, and here we can see those VLANs we created. Now we will assign ports to its respective VLAN. Here we can see student PC1 is connected to fast Ethernet 0/1 on S1, and PC2 is connected to FA0/1 on S2. So we will assign these ports to VLAN 10. And here we can see this staff PC1 is connected to fast Ethernet 0/2. We will go to that interface FA0/1, where our student PC1 is connected. A switch port mode access VLAN 10. Now we will go to this interface FA0/2, which is connected to staff PC1, and we need to assign to VLAN 20. Interface FA0/2, switch port mode access VLAN 20. We can verify the configuration. Do show VLAN brief, and here we can see FA0/1 is assigned to VLAN 10 and FA0/2 is assigned to VLAN 20. In the same way, we will do it on S2. So FA0/1 is connected to student PC2. So we need to assign to VLAN 10. We will go to that interface FA0/1, switch port mode access VLAN 10. And here we can see FA0/2. We have a staff PC2, that is VLAN 20. Interface FA0/2, switch port mode access VLAN 20. Now we can verify the configuration. Do show VLAN brief. And here we can see those interfaces are to its respective VLANs. Now we are going to configure port channel LACP, and here we can see we used redundancy here between S1 and S2 and connected to G0/1 and G0/2. So first of all, we will go to S1 and we will configure LACP. We will go to those interface as a range, that is G0/1 and 2. So we can give -2. And here we are going to create the channel group. We'll give one mode active. So this active is for LACP. Okay. Now we will go to the other side on S2. We'll go to interface as a range G0/1 and 2. So we'll give 1-2. Channel group 1 mode active. Now we can see both side of this switch turned green, and we cannot see any blocked port here because we have a single connection from S1 to S2. We have port channel now, so we can verify that. Do show Etherchannel summary, and here we can see the details. We can see the group 1, then port channel 1, and the protocol used is LACP, that is link aggregation control protocol. And here we can see the ports we used to bundle, that is a gigabit Ethernet 0/1 and 2. Also we can see this interface is created. Do show IP interface brief, and here we can see that port channel 1, we did not assign any IP address here, and we can see its status up, protocol up. So here very easily we created LACP port channel. Now we can see in this topology we have two VLANs, VLAN 10 and VLAN 20. So the communication between S1 and S2. So we must make two trunk so that it will allow the VLANs we created. Here we will give a do show VLAN brief. And here we can see this port channel 1 is in VLAN 1. We will go to interface port channel 1, and we will make this mode to trunk, switch port mode trunk. Okay. Also we will set the native VLAN, and also we can set trunk allowed VLANs. Switch port trunk native VLAN. We created 99 for native. Switch port trunk allowed VLAN will allow 10, 20 and 99 only. Now coming to the other side, and here we can see we get some warning message, inconsistency with the native VLAN, and here still we get this native VLAN mismatch discovered. So we will set the native VLAN, switch port trunk native VLAN 99. Perfect. And here we can see port consistency restored. Also we will give switch port trunk allowed VLAN. We will allow only 10, 20 and 99. We will verify this trunk configuration be done here. End show interfaces trunk. Yes, here we can see this port channel 1 is trunking with native VLAN 99, and also we can see the allowed VLANs. Coming to the other side on S2, end show interfaces trunk, and we can see this port channel 1 is trunking mode is on because we configured it manually. Then we can see the native VLAN 99 and VLANs allowed only 10, 20 and 99. Perfect. So we need to configure this native VLAN on the other side also, I mean on S2 also. Right, so we will go to interface port channel 1. So manually we will convert to trunk. Switch port, we can see here do show interfaces trunk. Okay, so let me give switch port. Okay, here we can see it's in amber color. Switch port mode trunk. So we configured LACP and also the trunk between S1 and S2, that is port channel 1. Now we will test the connectivity between these PCs. First of all, we will ping from student to PC1 to student to PC2. So here already we given the command. We can press up arrow from our keyboard. Ping 192.168.10.11 and we get the replies. Then coming to staff PC1, we will ping to staff PC2. Ping 192.168.20.11 and we get the replies. In the next video, we will see how to configure Etherchannel port aggregation protocol, that is PAGP, a CISCO proprietary protocol. So stay connected. We will meet again in the next video. Thank you.